Hi, my name is Olu. Today, Launa and I are going to talk about a palm oil deforestation tracker that we built with our team members, Tim Hannifan, Daniel Lee, and Amanda Whaley in collaboration with Inclusive Development International. First, we'll talk about our problem statement and motivation, give an overview of our mill and brand analysis, show you a demo of the tracker, and go over our challenges and future work. IDI focuses on four main areas: policy research and campaigns, which means advocating for strong human rights regulations; individual cases, working with communities to hold various entities accountable for human rights and environmental violations; following the money, which is done by using trade databases to unravel complex webs of harmful investment projects; and community empowerment, developing tools for communities to fight for inclusive development. Our problem statement is empower communities by building a public dashboard to inform consumers about brands' deforestation impact in the palm oil industry. First, a quick note about palm oil. After 30 months of growing, the harvested kernels are sent to mills within 50 kilometers of a plantation, otherwise they spoil. The fruit is sterilized and pressed to produce oil and further refined to different quality levels. It is the most efficient vegetable oil crop, requiring much less land per ton of output compared to other vegetable oils. It's a contributor to rapid forest loss, leading to carbon dioxide stored in forests to be released into the air. Production continues to grow and has been doubling every 10 years since the 1960s. To solve some of these issues, the Roundtable on Sustainable Palm Oil was created in 2004. It's a nonprofit that unites stakeholders in the palm oil industry to develop and implement a global standard for sustainable palm oil. Later, we'll show you how some analysis we did calls into question whether or not the RSPO certification leads to a significant difference in deforestation. This is how palm oil has historically been tracked. It's easy to see which mill different brands might be sourcing from, but attributing that to a plantation was a little more difficult. The tool we will later show you now lets you see how much deforestation the mills are responsible for and tracing that directly to a consumer brand. We chose Indonesia as our first country because it's the world's largest producer of palm oil, responsible for 48% of global production. Production has grown from 600,000 hectares to 12.8 million in 2018. Roughly 47% of deforestation in Indonesia is a result of this explosive growth in production. We use the Hansen Global Forest Change via the Google Earth Engine to get pixel level data, the universal mill list produced by the Global Forest Watch, and a universal mill list to consumer brand match list that we created, matching consumer brands to specific mills. Our methodology starts with matching palm oil mills to particular brands, finding how much tree loss is associated to a mill, then computing a past damage and future deforestation risk for each mill. Then we aggregate the risk data for each brand. The brand data was stuck in their PDFs, so a script was created to scrape those websites to get the mill data that brands post and put that data into a table we can use for analysis. We added some rules based on distance and mill names to get a roughly 85% match between the mills that brands publish and those on the UML. In order to calculate risk for a mill, we needed to attribute tree loss to a particular mill. First, we needed to define an area around each mill representing where that mill was likely operating. This is best done via geospatial analysis. We tried two methods to create the areas around mills. Initially, we tried the same method as the World Resource Institute, which was to draw a 50-kilometer circle around each mill and sum up the tree loss in the area. We noticed, however, that this caused an overlap in the locations where mills are located close to each other. This overlap resulted in overestimating the tree loss attributed to each mill and made it nearly impossible to attribute deforestation to a single mill. We then tried using a Voronoi partition, which essentially takes a group of points in some area and separates each point into a polygon that does not overlap its neighbors. From there, we trimmed down these polygons using a 50-kilometer buffer to make sure none of the mill's polygons were unreasonably large. This process allowed us to attribute each pixel of tree cover or tree loss to the nearest mill. One industry expert we spoke to, Peter Vandermeer with the Van Hal Liechtenstein University of Applied Sciences, mentioned around 90% of a farm's output goes to the nearest mill. So the Voronoi approach has some justification as a reasonable approach to this problem. This is a snapshot from one view of the tracker. You can see each mill, which is color-coded by risk score. Yellow is low risk and red is high. On the left here, you can see the overlap problem in action. Notice the red to dark red stripe going down the middle of the map. Since those mills are clustered so close together, the radius method caused us to overcount their tree loss and assign them all roughly the same risk score. On the right, you can see the Voronoi partitions. Each mill is clearly separated from its neighbors, so we get a better idea of what's happening in the areas surrounding each mill. You can also see that there's more variability in the scores, shown by the colored markers. Even in the areas with a dense clustering of mills, we see orange, red, and dark red polygons in close proximity. We created risk scores that scaled from 1 to 5 using deforestation data from Hansen. These scores are relative to the average behavior of all mills. So a risk score of 1 means that mill is far below average, 3 is near the average, and 5 far above average. For past risk, the metric that we use is cumulative deforestation since 2001. For current, we use the rate of deforestation in the most recent 2 years. And for future risk, we wanted to capture the potential deforestation harm a mill could do if they aren't regulated properly by RSPO or other governing body. For this reason, we chose to include both the current rate of deforestation and how much untouched forest is left in the surrounding area of the mill in computing the future risk score. We looked briefly at the correlation between RSPO certification and deforestation, and what we found surprised us a little. Certified mills had deforestation in 2019 that was higher than non-certified mills, and the difference was small, but statistically significant at a 5% level. We think more analysis in this area is warranted. And now Launa will take us to the web app demo.
Thanks, Olu. Hi, my name's Launa. In parallel with our effort to develop relative risk scores for mills and consumer brands, our team also built a web app that would allow users to explore and interact with the data set. Our minimum viable product for our 10-week class was to target one specific user story, an environmentally conscious consumer hoping to make more informed purchasing decisions for products containing palm tree oil. As such a consumer, one might ask, what brands are the best and worst performers? What's the rate of historical tree loss per brand and across brands in aggregate? This web app, to the best of our knowledge, is the first to bring together disparate data sources to begin answering those questions. To dive in, we see that upon page load, the map is centered on the country of Indonesia, which was the focus of our project. If we zoom in more, we can see more clearly the marker icons that represent UML mills. As stated earlier in the presentation, the mill markers are colored by current risk score, with darker markers representing higher current risk and lighter markers, such as the yellow and orange ones, representing a lower current risk. Clicking a marker launches a pop-up that shows the mill's name, district and province, and past, current, and future risk score. We also see, as a layer on the map, the Voronoi boundaries that surround each mill. Moving to the left side of the web app, we see an option to launch a modal pop-up that gives context of the project and defines variables used throughout the site. And we also see the option to launch a pop-out window that displays the consumer brands that we analyze, currently 13. Looking to the right side of the app, we see an aggregate consumer brand snapshot showing high-level statistics across brands, as well as some interactive charts showing tree cover loss and distribution of mills per brand. We also see a list of brand ranking from highest current risk score to lowest current risk score. Interestingly, when we were analyzing the data, we noticed that all the brands had roughly the same average current risk score, around 3. Some brands sourced from mini mills, so their risk score made sense. They're sourcing from the majority of the mills in our data set. Other brands had fewer mills, but still had the same average risk score of around 3, which suggests that brands may not be considering a mill's track record in terms of deforestation when deciding which mills to source from. So we can actually filter both the map view and this side summary view simultaneously by choosing a brand to filter by. So if I zoom out now and then select a brand for analysis, such as Ferrero, we'll see that both the mill markers and the summary card have changed just to limit information in that particular brand. And you can switch between different brands and the map will update accordingly. I can also launch a full report view of a brand to get more detailed information about that brand's deforestation risk, as well as a list of their supplier partners and mills. Overall, we're very excited for the direction of this project, and I'll leave it to Olu to talk a little bit more about that.
Thanks, Launa. We face a few challenges working with the brand and mill data available to us. We think these factors should be taken into account when interpreting the results of our research and offer suggestions for future improvements to the project. The first issue deals with the lack of historical data. Without this information, we can't determine when mills were created or added to the list, or when a brand started sourcing from a particular supplier. Tree loss is aggregated over the entire 20-year period using just a snapshot of a brand and mill from 2019. Second, we don't have data on the volume of activity between brands and their suppliers. Since one mill might supply several brands, we had to assume that each brand got an even share of the mill's output. Some brands could potentially take a much larger share of a supplier's output and thus have more of an influence on the supplier's behavior. Last, there's some issues with attributing tree loss due to other reasons. We assume that all tree loss in a mill's polygon was due to that mill and not from other industries or illegal mill activity or other factors occurring within the polygon area. In order to improve the risk score analysis, we think there's more work to be done on attributing tree loss to mills. One approach we think has potential is to apply a probability distribution with distance decay to estimate tree loss. The idea here is that each tree may have been cut down by one of the mills in its proximity, but we're not sure which mill is responsible. So we assign some probability to each one with lower probability placed on mills further away. Another potential avenue that could yield interesting results is to apply computer vision and pattern recognition techniques to the Hannifan data. Mature palm fields have a very specific and recognizable appearance, as you can see on the image in the right. Computer vision could potentially allow us to distinguish newly cut forest from mature plantations, predict the path of deforestation in pristine forests, and narrow the scope of our data to include only palm oil related activity. We also could add search functionality for mills, brands, and regions, as well as add new countries and brands to our analysis. We want to say thank you to the 11th Hour Project for being the project sponsor, IDI for allowing us to participate on this project and helping us learn more about the connection between palm oil and consumer brands, and the University of Chicago. Specifically, thanks to Dustin Roasa from IDI for giving us some feedback on our web app and methodology. And lastly, David Uminsky and Daniel Grisenda for being great mentors throughout this process and helping us learn new methods for evaluating data and guiding this project along.